Okay, so previously we looked at the formula for L'Hopital's rule. Let's look at a few examples of problems where we could use L'Hopital's rule. Now, L'Hopital's rule becomes useful where you have an indeterminate form. But let's look at this situation where f of x divided by g of x is not indeterminate. Suppose, for example, you have x plus 6 divided by x plus 2 as it is the limit as x approaches 3. Now what would that mean in this case? If you directly substitute, you have 3 plus 6 divided by 3 plus 2. I wrote x up top here, should be 3. 3 plus 6 over 3 plus 2 gives you 6, 7, 8, 9 divided by 3 and 2, 5. 9 fifths, alright? So you would need to use L'Hopital's rule on this, but suppose you use it. Then, when you differentiate x plus 6, what you get is 1 divided by, when you differentiate x plus 2, you get 1. Now, here, L'Hopital's rule does not work on this example because, of course, you could very well have found the limit otherwise. Now, suppose we start again and make a little adjustment. In this case, you have x squared plus 6 divided by x squared plus 2. As x approaches 3, what is the limit? Let's substitute directly. So it's 3 squared plus 6 divided by 3 squared plus 2 would give you 9 plus 6 divided by 9 plus 2. 9 and 6, 15 divided by 11. It's 15 over 11. Now, suppose you use L'Hopital rule on this anyway, even though you found the limit. You would have, when you differentiate the numerator, you'd have 2x divided by, when you differentiate the denominator, you have 2x as well, right? And then when you substitute 3, you get 2 times 3 divided by 2 times 3, which will be 6 divided by 6, which is 1, which of course would be incorrect. And no, it's incorrect because suppose you try to substitute a number close to 3. For example, 2.9. 2.9 squared plus 6 divided by 2.9 squared plus 2. So we reach for our calculator and deal with that. This is one sure way for you to find a limit. So in this case, 2.9 squared plus 6 is that 14.41 divided by open bracket 2.9 squared plus 2 close bracket equal 1.384, and 15 divided by 11 should be close to it, 1.36 something, close. Alright, so the limit is 15 divided by 11, not 1. So if you are able to find the limit of the function otherwise, you don't use L'Hopital's rule because it may give you an incorrect answer, as in this case. Now, suppose we change our function again and say we want the limit of x squared minus 16 divided by x minus 4 as x approaches 4. How would this one go? If you make a direct substitution, what you would get is 4 squared minus 16 divided by 4 minus 4. You'd have 16 minus 16 divided by 4 minus 4. So you'd have 0 divided by 0. Okay. Now, since we get a 0 divided by 0, let's try L'Hopital's rule on it. And then we're going to consider yet another method. So, L'Hopital's rule. If you differentiate x squared minus 16, what do you get? You get 2x divided by differentiate x minus 4, you get 1. So the limit as x tends to 4 of this is, let's substitute 4 into it. 2 times 4 gives you 8. That's what it says. But suppose we consider another method of solving it other than L'Hopital's rule. What we could do is factorize the numerator. So in this case, x squared minus 16 is the difference of two squares. So we have x plus 4, x minus 4 up top divided by x minus 4, and the limit as x tends to 4. Now, notice x minus 4 cancels x minus 4. So we have the limit as x tends to 4 of x plus 4 is going to be, when you substitute 4 plus 4 equal 8, the same 8 that we got. Alright, when we use L'Hopital's rule. L'Hopital's rule worked this time because when we had tried direct substitution, we got 0 divided by 0 in determinate form. Alright, so using another method by cancelling, factorizing and cancelling, we get the same answer as we got in L'Hopital's rule. Alright, so that's it for now. I'll see you in the next video.